Hello students. So I'm going to share from right here at my desk the key concepts for the beginning, the first 3 quarters of lesson 13.4. So this will cover most of the exercises you can do. Then on Wednesday when you return after the weekend and the break, we will cover one more concept and do some exercises. Then depending on how you're feeling about the content, we'll either do a review and a quiz on Thursday, or we'll do review on Thursday and a take-home quiz. So whichever you prefer. So that'll be depending on kind of how you feel next Wednesday. But we are now we're using our understanding of exponential functions and the new base e to talk about some particular instances of using exponential functions to calculate some things. So we're going to be talking in this lesson about investments. So there are 2 key terms you need to understand with an investment. One key term is principal. So the principal is the money you put in at the beginning. Okay. So if I put $500 in an account and then it gains interest, that $500 is my principal. And we might even say in that instance that it's initial principal. Okay? So now there is a kind of interest that is simple interest, and it is never compounded. And for the most part, when you're talking about investments, you don't have to worry about this. This would be like at the end of each year, interest is calculated, you get that interest, and the principal stays in the investment. But now, compound interest means that I've put money in. At the end of some period of time, a percentage of that money is generated as interest. Okay? And then when that interest is generated, it's added to the principal. And my next interest return is calculated off of the new principal amount. So for instance, let's say I was dealing with 3% interest. I had an investment that was giving me 3% interest, and it compounds annually. What would happen is, let's say I put $1,000 in. Okay, so I put $1,000 in. It's in there for a year. At the end of the year, 3% gets given to me as interest because of the kind of saving. So that's $30. So now my new balance is $1,030. That becomes my new principal. So for the second year, I have $1,030 in there. Excuse me. And then my 3% interest is calculated again. So for instance, that would be, now it's at $1,030, 3% of that would be $30.90. So my interest at the end of the second year is $30.90. That gets added on to the principal, which is $1,030. So now I have $1,060.90, and that's my new principal amount. For the third year, at the end of the third year, 3% is calculated again. So what we're talking about when we say compound interest means that interest is being generated off of some investment or some asset or something, and that interest is then being added to the principal, and the next interest payment is calculated off the new principal amount, with the principal and interest added together. Now in class, Ethan mentioned that his knowledge of the term interest has to do with debt. That would actually be the reverse side of what we've just been discussing. So typically what happens is, like, I put money in a bank, and if I put it in a particular kind of savings account, that bank loans it to people. The people who borrow it have to pay it back with interest. So if they have debt to the bank, they pay the money back with interest. So that's like the fee for getting to borrow the money. Now, when the bank loans the money to people and they pay it back with interest, a piece of that interest comes to me. So the bank might be loaning it at 8%, so the person who borrows it has to pay 8% interest. I get 3 of that, and the bank keeps 5. This is how banks make money, by loaning money and charging interest. So anyways, that's just a quick kind of primer on principal and interest, because those are going to be terms that we're going to use heavily in this lesson. Now we're going to talk about 3 ways to calculate interest. Okay, if it's compounded annually, if it's compounded more than once per year, so compounded annually means compounded one time a year. Then if it's compounded more than once per year, and that could be every 6 months, every 3 months, every 4 months, every month, something like that, but more than once per year. And then if it's compounded continuously, so just kind of always adding the interest back in, not coming to a stopping point. So first of all, on page 683, you'll see the explanation of how to calculate interest on an investment when the interest is compounded annually. So that is generated by this formula. So this looks a lot like what you've done already with an exponential growth model. So this V of t represents the total value of the investment. So with what the investment is worth at a particular time t. This P is your principal, it's how much money you put in to start. R is the rate, and T is the time. So you'll recall the time in years. So you'll recall that when we were working with exponential growth functions, we did 1 plus R because each subsequent term value is generated by taking the original term value, multiplying by R, which is a percentage like 0.2 or 0.05, right? 0.05 is 5%. We would take 5% of P and add it to P, right, to find the total value. So this is very simple, compounded annually. This means that each year we recalculate the total principal, okay? And for each year is 1 plus R. We multiply by 1 plus R for each year. Okay? So this is your compounded annually formula, just like an exponential growth. Now, what if it's compounded more than once per year? Your example for that is on page 684. Okay? Compounded more than once per year. So this means, like, let's say it was compounded quarterly. That would mean that you go 3 months, you calculate the interest, add it to the principal, go 3 months again with that new principal amount, and at the end of the next 3 months, calculate the interest again and add it into the principal. And so every 3 months, okay, you are calculating the interest and adding it to the principal. So for instance, but the interest rate is still communicated as an annual interest rate, all right? So you're still saying it's a 2% annual interest rate compounded quarterly. Like that's the example on page 684. So this is now your formula, where the value of the investment equals the principal times the quantity of 1 plus the rate over the number of times per year it is compounded, all raised to the number of times per year it's compounded times the number of years. So for instance, if you're compounding quarterly, its n would be 4. And if you did it over 5 years, it'd be 4 times 5. Your exponent would be 20 because there'd be 20 times that you compounded it. 4 times a year for 5 years is 4 times 5, 20 times that the interest was compounded. R over n is because your R is an annual interest rate. So at the end of 3 months, right, you've only generated 1/4 of the annual interest. So if you say rate divided by 4, because every 3 months you've only generated 1/4 of the interest, right? So it's essentially the same formula. We just factored in these n's to account for the fact that we're compounding, if n is 4, we're compounding quarterly. If it's compounded monthly, n would be 12. If it's compounded every 6 months, n would be 2. Okay? So this is your formula for if the interest is compounded more than once per year. The value of the investment equals the principal times 1 plus the annual rate divided by the number of times per year, all raised to the value of nt. Okay? The number of times per year times the number of years. So that is compounded annually and compounded more than once per year. And these are pretty simple. These are all rational numbers. They're all, rational, terminating, right? They're rational numbers. So these are pretty simple. Now, but in reality, if you've got a savings account with a bank or an investment, your interest is actually being compounded continuously. So they are rarely going, okay, we're going to stop every 3 months or stop every year to calculate the interest and add it in and then start over. That's not generally how it works. So this is the formula for a investment where the interest is compounded continuously. Okay. And this is on page 685. 685. So, and on page 685, they go through sort of a complicated derivation where there's lots of variables floating around. But ultimately, what they get to is that the value of the investment equals the principal times E, the base E that we've dealt with, that's an irrational number, an irrational constant, raised to the RT, the rate, times the time in years. Okay? Time in years. So you have the principal, the amount you put in. E is an irrational constant, so that will never change. And E is raised to the RT, rate times time, time in years. Okay? Rate expressed as a decimal. So, yes, and that's important to note. All the rates here are expressed as decimals. Okay? So all of these R's are decimal forms of the percentages that you're given. So we will later learn how to convert all of these to annual returns. But for now, over the weekend, I want you to do some exercises that deal with just calculating interest in these various forms. So what you're going to be practicing doing is using those formulas, plugging in numbers to generate values of investments. Okay, so we're going to do that on a few. I'll put the exercises in Sycamore, and you do the exercises I put in Sycamore. They will give you practice on dealing with these three formulas. Then when we return together on Wednesday, we'll take a look at how to massage those formulas, kind of rearrange those formulas to show us annual returns so we can compare one investment to another. So for instance, like if it's a certain annual rate of return but it's compounded quarterly versus compounded annually, why would you make more with one than the other, right? So we'll look at that when you get back. But for now, I just want you to use the formulas I've shown you to calculate values of investments in the exercises. So I'll post that on Sycamore, give them a shot, come back on Wednesday, and we'll talk about it. All right? Happy mathing.